All right, so 3.2, sine, cosine, tangent, part B. Do you have your half sheet? It should be a little half sheet. No, we made it into -2. Well, I mean, you can divide. Part B is a half sheet. Well, I told you we're working to the bell. Already told you. All right, here we go. So up next, more vocabulary. A central angle is an angle whose vertex is at the center of a circle. Very obvious. Okay, that's a central angle. Interceptic arc. Interceptic arc is the portion of the circle whose endpoints are the sides of the central angle. So this is my arc. This is my interceptic arc. This is coming from, the first two words should have been from geometry, not me. I don't know why you didn't listen in geometry, but I hope you did. All I said was central angle is from the center. This is your central angle. And then the intercepted arc is the ends that intersect the circle. That's it. You missed nothing. All right, radian. Okay, this is a new. So thus far, we've been measuring everything in degrees, right? Yes. All right. What we're introducing is our radian measure. Okay. It is 1 radian is the measure of a central angle of a circle that intercepts an arc equally in length. So it's just 1 radian is rotating around. Okay. So when we're talking about this, this is our rules for radians. Your circumference is normally 2 pi r or pi times d, correct? When we're talking about radians, your circumference is now 2 pi radians. So to go all the way around the circle, that's 2 pi radians. Okay? To go halfway around the circle, that would just be pi radians. Does that make sense? So all the way around, that's 2 pi radians, which is equivalent to 360 degrees. To only go halfway around, that is 1 pi radian, and that is 180 degrees. Okay? Yes? Okay. So they're equivalent. So how do we convert between the two is what we're going to write out. In some form, yeah. Okay, so to convert from degrees to radians. So if I'm going from degrees to radians, I'm going to do what? Anyone wants to take a step? I mean, you learned this. Multiply by, it's your angle times pi over 180. Okay, if you're going from degrees to radians, it's the angle times pi over 180. Okay, to convert from radians to degrees, it's the angle times 180 over pi. Yes? Okay, so degrees, so D to R to D. Are you ready to try it? Why not? So it says find the radian measure of 60 degrees of a 60-degree angle. So we're doing D to R, so we're using this rule. So we have 60 times pi over 180. These conversions will be on non-calculator part of your test. So you have to be able to do it without a calculator. What? So before you jump to a calculator, let's go over some basic math. Okay? You can turn any number into a fraction by putting it over 1. The zeros cancel out because I can divide both numbers by 10. Agree? That's going to leave me with 6 pi over 18. Can I continue to reduce 6 and 18? How do I do it? No. Keep going. I can reduce some pi over 9.
6 can go into 8. So
we're going to divide both by 6.
Yeah, you divide both by.
We can divide both by 6. And we get pi over 3. And that is your radian measure. You were getting there, but we're a little cool sometimes. Okay? All right. I want you to try B. Go.
of radians.
Just divide by 5, right?
Oh,
17? Five goes into 18. How many times? With the remainder of. So 5 goes into 30. How many times? 5 goes into 30. How many times? So your answer is. There we go.
so
We know how to divide.
5 over 1 times 5 is 180. You just go across.
Mhm.
So 180 would stay 180.
Mhm.
Yeah.
You said 35.
Pretty sure I said 36. All right, let's go over it. So we have 85 over 1 times pi over 180. Multiplication of fractions, numerator times numerator, denominator times denominator. Math 101. So 85 pi over 180 is an answer. It is not your reduced answer. Okay? Both of these are divisible by 5. So I would divide both by 5. 85 divided by 5 is? And 180 divided by 5 is? So your reduced form is 17 pi over 36.
How would we have figured that out?
What do you mean?
I just figured out that. I know you're dividing by 5. but-
That's it.
You better pull out your fingers.
So, hold on, let me. Oh, that's no bueno. All right. All right, last one is going from radians to degrees. So we're going from radians to degrees. We're going to be using r to d, which is theta times 180 over pi. Now, notice that 2.5 is not given as a fraction, right? However, can we convert 2.5 to a fraction? Yes. What is 2.5 as a fraction? Other way. It is 5 over 2. So 2.5 is the same thing as 5 over 2. Agree? Times, and we have 180 over pi. And I can do, 36? How'd you get 36? 180 and 2. They have to be numerator and denominator.
Got 450 over 5, does that count?
So you can, yes. So 2 and 180 can simplify. 2 divided by 2 is 1. 180 divided by 2 is 90. 5 times 9 is 45. Times 10 makes it 450. So 450 over pi would be your exact form. Yes? So this is my exact value. If it asks for an approximation, you would just put this entire thing in the calculator. Does that make sense? Yes. Yes, this is where we were to stop. I wanted to finish the front side. Okay. All right. So again, 450 over pi is my exact. I would put that in the calculator to get my approximate degree. Make sense? Okay. And then that's just a calculator. It may not be.
Well, you said approximately